There were some questions about the cerebellum, so I've recorded a couple slides as a supplement to my prior talk. Let's first review the efferent fibers of the cerebellum. The efferent fibers start in the axons of the Purkinje cells, which project into the deep cerebellar nuclei. These include Purkinje cell axons from the vermis that go into the fastigial nucleus, the intermediate zone which project into the globus and emboliform nuclei, and from the lateral zone that project into the dentate nucleus. As you can recall, the dentate nucleus is the largest and most important of the deep cerebellar nuclei and contains that information from the cerebellar hemispheres. This relationship is depicted here with those Purkinje cell axons projecting into the dentate nucleus on the same side. The dentate cerebellar nuclear fibers then form the superior cerebellar peduncle and is made up of three main tracts: the cerebellar tegmental tract, the cerebellar rural tract, and the dentado-thalamic tracts. I did not tell you about these tracts before, as it is unlikely you will be tested specifically on them in the future. What happens with these tracts is that they will enter the upper pontine tegmentum, decussating at the level of the inferior colliculus. Some of these fibers will synapse in the red nucleus, some will synapse in the pontine tegmentum, and others will pass right on up to the thalamus into the ventrolateral thalamus. Let's look at how this happens. So here we are in the dentate nucleus, and you can see that these tracts are passing through the superior cerebellar peduncle, decussating over in the pontine tegmentum, with some of these fibers synapsing in the red nucleus and in the pontine tegmentum, and other of these fibers going all the way up into the ventrolateral thalamus. Now the next set of fibers will move from the ventrolateral thalamus up into the supplementary motor cortex, and you can see these depicted here. Now this information from the cerebellar going into the supplementary motor cortex is going to complement that information that the corticospinal tract is going to be carrying back down. The cerebellar information is essentially modulating the movement that is coming with the body, and so that information is going to come down and carried with the corticospinal tract. Now, as you recall, the corticospinal tract, which starts up here in the frontal lobe, is going to come down, descend, and then cross over and be on the contralateral side. However, because it is crossed over, it is on the ipsilateral side to the cerebellar hemisphere lesion. So again, let's review. The reason that the lesions in the cerebellum cause ipsilateral findings is that the corticospinal tracts cross back over. So if you have a lesion here in the cerebellum, that information is decussating in the upper pons, moving up into the supplementary motor area, communicating with the corticospinal tracts, which are going to come back down and decussate on this side. So the ipsilateral cerebellar lesion is going to be located on that side. Now the afferent inputs to the cerebellum are many, and they tend to enter primarily through the middle and inferior cerebellar peduncles. They are ipsilateral. These afferents include the mossy fibers, which are axons of the spinocerebellar tracts. There are multiple spinocerebellar tracts. The most important are the dorsal spinocerebellar tracts from Clark's column, which carry proprioceptive information, the cuneo-cerebellar tract, which carries information from smaller receptive fields, the ventral spinocerebellar tract, which carries the flexor response, and the rostral spinocerebellar tracts, which is bringing information from the arms. These mossy fibers also include axons from the vestibular nuclei and the lateral reticular nuclei. Afferent inputs also include projections from the pons and includes climbing fibers from the inferior olivary nuclei. Now, lesions in the afferent inputs will manifest in ipsilateral findings because the efferent system is getting the wrong message from the afferent tracts, so the corticospinal tracts are still bringing the wrong message down. So typically, again, we will have a lesion in the cerebellar fibers on one side, and that will manifest in ipsilateral findings because the efferent message being brought down through the corticospinal tracts is going to be the wrong message. Hopefully this clarifies the relationships to the cerebellum.